Finding the domain and range of a function can be pretty frustrating. It's really easy to miss some pockets in the graph. Maybe you're dividing by zero. I'm sure you've been there, and I have too. I remember in college sometimes stumbling on some of these homework problems. You've come to the right video if you can relate, because here we're going to make this process really easy. And I'm going to show you graphically the simple way to find the domain and range of any function. Now, the function I'm giving you here in particular is a piecewise function because it demonstrates some common mistakes we have to avoid when trying to find our answer. Now, if you haven't seen the definition of a domain or range, that's okay. It's actually pretty simple. The domain is simply a set of all the valid values of x. And similarly, the range is the set of all valid values of y. And it's going to be easier to visualize this as we dive into the problem graphically. But before I do, if you haven't already, hit that subscribe button and let me know in the comments below what kind of example domain and range problems you've seen and some of the frustrations you may have had. And I'll see how I can help you guys out with future content. Going into the graph, we graphed both parts of the piecewise function. The left-hand side happens to be the part that is 1 over square root of x, and the right-hand side is the parabola I gave you, which is demonstrated by the function negative x minus 2 squared plus 2. The first graph is very interesting on the left-hand side. You'll notice that I gave you a range from -1 to 1, but it's not exactly what I graphed. Do you notice that I didn't graph anything between -1 and 0? And why is that? Pay very close attention to the original function. You have a square root of x on the denominator. My tip for you is that anytime you have to find the domain and range of a fraction, pay very close attention to the denominator. Two major mistakes we make. Either one, we forget about values that would cause you to divide by 0, which wouldn't be allowed. And two, we sometimes forget that we can't take the square root of a negative result. See, if you plug in a value of, say, -0.5 or -1 into the x variable, you'll get a result where you're dividing by the square root of a negative, and that's not going to be allowed. Similarly, you just can't plug in 0 here because 1 over 0 is undefined. So even though I gave you the graph spanning a range of -1 to 1 on the line, we can only graph what's called the open interval from 0 to 1. And what do I mean by an open interval? Well, the graph is open at x equals 0 because we have an asymptote here. You'll notice that if I were to approach the y-axis from the right, this part of the piecewise function rapidly approaches infinity. But x equals 0 cannot be contained in the set of the domain because you simply can't divide by 0. So the way we can draw this is with a square brace and an open brace. And if you look down here, for example, the domain is going to be an open interval from 0 to 1. And the way you can understand better what this means, when you have a square brace, such as the left-hand side of -1 to 1, it means that part of the domain is included. Versus if you have an open curly brace, say for 0 to 1, as I'm showing you here, that is like a hole. That is a part of the graph where you can approach it, but it's not part of your answer. And so even though I gave you an original range of -1 to 1, notice how even in the piecewise function itself, the right-hand side portion of my range, that x is less than 1 part, is open. It would be closed if I told you x is less than or equal to 1. And that means that just like on the left-hand side of the interval, we have openness at x equals 0. That means that we also have openness on the right-hand side of the interval at x equals 1. And the way I drew that graphically is I drew this open circle here, as you can see. So we're seeing then that the domain of the first part of the graph is the open interval from 0 to 1. And okay, well, what is going to be the range of that first part? Well, you can tell the minimum value of y is 1 and the maximum value goes to infinity. So because the interval itself is open at x equals 1, that means that we have to leave y equals 1 as open as well. And that's why I'm drawing this open brace. Similarly, you can't contain infinity. It's unbound. It goes on forever. So that portion of the graph is going to be open as well. Okay, let's move on to the second part of the graph. This parabola that's described by -x minus square 2 plus 2. Here in this example, I've created a closed interval from 1 to 3 because I'm using the less than or equal symbol for both 1 is less than or equal to x and x is less than or equal to 3. So it's inclusive on both sides. On the graph itself, you'll notice that that right-hand parabola is filling in the graph at x equals 1. That part that the left-hand side left open, we are now closing it. Similarly, from 1 to 3, it's completely closed. And you'll notice that for a parabola, we're not dividing by anything. We have full continuity. We can plug in any value of x between 1 and 3. And we're not going to have to worry about dividing by 0, taking the square root of a negative, etc. So for this right-hand side, the domain of that portion is going to be the closed interval from 1 to 3. And similarly, its range is going to be from a minimum value of 1 to a maximum value of 2. And this in itself is one of the other pitfalls you have to watch out for. If you simply just relied on taking this interval 1 to 3, plugging in the value of x equals 1 and x equals 3 to find your minimum and maximum values of y for the range, you would totally be missing out on the fact that there's a maximum value of 2 at x equals 2. So this is where a graph can actually help you. And if you want to do this mathematically for something like, say, a parabola, etc., this is where derivatives come in handy, because you can then take the first derivative and find out where that parabola has a max or a min. And if you haven't seen derivatives already, or if you want to brush up on them, be sure to check out this playlist as well. Okay, so now we have these two parts of a piecewise graph with their own respective domain and ranges, right? You got the first part that goes from 0 to 1 for x and from 1 to infinity for y. And then for that second part, that parabola, the x part, which is the domain, goes from 1 to 3. And the y, also known as the range, goes from 1 to 2. So we're done, right? Well, not quite. We need to now stitch these answers together to get the overall domain and range of f of x, this piecewise function, right? And the way you can do this, you're going to be using this symbol called the union operator. It looks like a fat U, and it's grouping together whatever you have on its left to whatever you have on its right. So by bringing together the answers for the domain and range for both that 1 over square root of x function and the quadratic to the left and right hand side of the union operator, what you want to look for now are overlaps. Notice how when comparing the open interval of 0 to 1 along with 1 to 3, 1 is an overlap area. So a good rule of thumb is that if one part of the domain has openness at that number 1 and the other part has a closed interval, the closed interval basically closes the value of 1 in your answer. If you're open at 1 and closed at 1, you're basically closed at 1. The other thing you have to watch out for on your homework too, and this is another pitfall, is that sometimes you might have pockets, right? Just because you have 0 to 1 on the left and 1 to 3 on the right, we have to take caution because you may sometimes miss the fact that, say, the graph isn't defined at x equals 2. We don't have to worry about it here, but it's just something to be mindful of. So when you bring together with the union operator these two sets, you're going to get a final domain of 0 to 3. And notice how 0 is only part of that 0 to 1 range. And because it's open there with that open brace, in our final answer, 0 cannot be contained, right? Because we have an asymptote there. And this goes from 0 to 3. 3 is closed here because in that interval for the parabola, where you have the range 1 to 3, it's closed on both sides. And similarly, the range, you use the same strategy. Going from 1 to 2 as a closed range closes 1 for the first part of the graph because, again, if you have one set closing 1 and the other one leaving openness at 1, you're just going to close it at 1. Similarly, the graph has a range that goes from 2 to infinity because you'll notice that the maximum value of the graph is infinity due to the asymptote at x equals 0. And so grouping these together, you finally get an answer that includes 1 and is open up to infinity. And make sure to avoid that mistake too. You can never include infinity as a closed interval. It's unbounded, right? So you need to make sure that you give an answer where infinity has an open brace. So I hope this video was helpful to you. Let me know what you think in the comments. And if you haven't checked out this other playlist, be sure to follow these other example pre-calculus tutorials.